Okay, this question asks us to identify the functional group below. Now, there are a lot of potential functional groups. We're going to break these down into what we're looking for in our class at the present time. So the first group ones we're looking at involve just carbons and hydrogens, as carbons and hydrogens only. And there are really three main ones. There are the alkanes, there are the alkenes, and there are the alkynes. And less common, we won't see many in this book, are the benzene derivatives or aromatic compounds. And what we can see to distinguish these, the alkanes are just carbon-carbon single bonds. So, and the alkanes are carbon-carbon double bonds, and the alkynes are carbon-carbon triple bonds. If you have if you have a triple bond anywhere in that molecule, you have an alkyne. Double bonds, alkenes; single bonds, alkanes. And then the benzenes, we see these two different ways in your textbook. It'll look like a cyclohexane with alternating double bonds, or, and these are both actually representing the same thing, it'll be a hexagon with a circle in it. And basically what that's saying, it's carbon-carbon double bonds, so kind of like an alkene, but the fact that they alternate in a ring makes it benzene, six-membered ring. All right, that is the ones that contain just carbon. Now, the next group that we want to cover, actually we're going to add one thing else to that. Still got carbon and hydrogen, but we are going to add a halogen, which we will mark with an X. Doesn't matter if the halogen is fluorine, chlorine, bromine, or iodine. We just call these haloalkanes or alkyl halides. I'm going to go with the alkyl halides because halos can't, or the halogens can be on alkenes, alkynes, or alkynes. So, but alkyl halide covers almost everything that we're going to possibly see. Now, technically, that doesn't actually affect the name. So when you have an alkyl halide, you just actually add the chlorine, bromine, iodine, or whatever as a substituent. But the other ones, the ones above us, these change the suffix. So these are ANEs, these are ENEs, and these are YNEs. And these are something different. We're going to leave that as a blank. Think about that as something to come for organic chem. And then the haloalkanes, go ahead and put them. We're going to have chloro, fluoro, bromo, and iodo. But these are actually substituents, so they're out in front with a number. I'm going to do that. They're going to be numbered locations every single time. There are no exceptions unless we're in a ring and there's only one thing. All right. The next group that we're going to look at are going to have oxygens in them as well. So I have CH and now O. Now, the simplest form of this are our alcohols, which just has somewhere off of the carbon you have an OH. And if you have that, the end of the name turns into an OL. The other one that's kind of fit in with this, with CHOs, are our ethers, and that's where the O is bonded to two things, but both of them are carbons. So it's carbon, oxygen, and carbon. They don't really get a prefix or a name, and we're leaving that another thing, kind of like the benzene ones, that's to be named properly later. Now, we're not done with the CHOs, but all these other CHOs specifically have somewhere in them a carbon double bonded to an oxygen. And this is a group that does technically grow as we go in. So the simplest form is with that carbon double bonded to an oxygen, and basically we'd say R and R. If they're both R's on both sides, so more carbons, you have what we call a ketone. If one of those things off of that is instead a hydrogen, you have an aldehyde. And those two actually behave somewhat similarly, but not exactly the same. little bit different. We're going to put that halogen off. So we're starting to combine things, but we don't call it an alkyl halide now. Since the halogen is off of a carbonyl, it's an ACYL halide. And they actually react a lot different than the alkyl halides. All right, the next thing that we're going to do, still with that same carbonyl, the carbon double bonded to oxygen, this time we're having it connected to an O and then an H. So kind of like an alcohol, but on the carbonyl, and you have that, you have a carboxylic acid. And if I rip off the H and instead have another R, it can be the same R or different, we have an ester, not an ether, ester. Esters typically have kind of pleasant smells. They're the thing that gives the stuff we smell when you smell like fruits and vegetables is mostly the esters. And I kind of have one more that's kind of tied in with my next group as well. So the group we're going to talk about here in just a second is going to have the R connected to that carbonyl, but instead of an O, it's now an N. Nitrogens have three things coming off of it. These could be anything, R's or H's. But if you have that, you have an amide with a D in it. And the final group, the last one we're going to look at, is going to include the nitrogens in there, but we're going to remove that carbonyl. So in this case, you have a nitrogen with at least one carbon attached to it. Doesn't matter what these other two are. They could be carbons, they could be hydrogens. Regardless of what it is, you have an amine, I-N-E, different than the amide. Now, there are plenty more that we could go over, but these are the critical ones for now, and those are the ones that our general chemistry textbook really covers.